Hello, this is Mr. Win again, and today I'll be going over properties of real numbers. First, make sure you know that numbers may be classified by their type. Every number you've seen is real, which is the letter R. Real numbers are then classified into two groups, rational, Q, and irrational, I. Rational is any number, fraction, or decimal that stops or terminates. This also includes any decimal that goes on forever with the repeat bar symbol. For example, 0.3 repeating goes on forever, but it's a fraction, 1/3. Irrational is any never-ending decimal that does not repeat or is random. It comes from square roots and special numbers like pi. After that, there's a special category that's integer, Z, whole, W, natural, N. These only work if they are complete numbers. So complete is like a solid, kind of like a whole number that you count with, like 1, 2, 3, 4, 5, 6, no decimals. Notice that integer is negative, 0, and positive. Whole is just 0 and positive, and natural is just positive. So they're very similar. Integer is everything. It's the freebie, it's like real. Then whole just takes off the negative. It's 0 and positive, and natural takes off negative and 0, and it's only positive. Make sure you follow the two notes. First one's be sure you simplify the problem first, and then note 2 is numbers can have multiple types. Here's a chart that has some examples. If you want to copy it, you can pause it here. Just make sure you know that every number has two requirements. First, you always have real, R. This is your freebie. If you don't have real or R in your list, it's automatically wrong. And the second requirement is Q or I, rational, irrational. It has to be one or the other, but not both. That's the minimum, having two. And then the special cases, if they're, again, complete numbers, then you can use Z, W, and N. So some examples, A is negative 23. First, my freebie, everything is real, R. Then my second requirement is Q or I. Well, this number does not go on forever, it stops, so it's Q. Then I think about the Z, W, N. Is this a complete number? Yeah, it is. So it's Z. Z is actually the freebie, it's any complete number, negative, 0, or positive. Then I think about, I use W or N. W is for 0 and positive, which negative 23 is not, and N is for positive, which negative 23 is not. If it's a negative number and it's a complete number, then it's just Z. For B, it's a square root of 50. For these, you're just going to have to use a calculator. So in the calculator, if I put square root of 50, I see the decimal 7.0710678812. It's a very long decimal, and it goes on forever. So I'll keep that in mind. But first, the freebie, it's R. Everything must have R. And the second requirement, Q or I. Well, it's I. I goes on forever. This is a decimal that does not stop. It's a square root that's not clean. C, the fraction, negative 2/3. Well, freebie is R. Then I need Q or I. Well, Q does fractions. It doesn't matter if it's negative or positive. Then I think about Z, W, N. This is not a complete number, so I stop. Just two answers there. D, negative 185. Well, the freebie is real. And then Q or I, well, it stops. So it's Q. And then the special cases, Z, W, N. Well, it's a complete number. So I use Z. And it's not positive or 0, so I can't use W or N. E, this looks just like B, but I have to keep in mind, just because it looks like B, square root of 50, does not automatically mean it's irrational. We have to simplify it first. So this is like a trick. We know the square root of 49 is a nice number. So this is really negative 7. So actually I'm going to do the letters for negative 7. Well, negative 7, well, first one's freebie, R, real. It stops, Q. It's a complete number. It's negative Z. And I don't do W or N because it's not positive or 0. Alright, F, square root of 95, use a calculator for that. If it's a nice decimal, then it's Q, but if it goes on forever, it's really long, then it's I. This one says 9.7467944345. It's really random, doesn't repeat, so it's going to be I. But let me do first one, freebie, R, and then I. There's nothing ever after I. Alright, G, it's negative 0.9 repeating. That little bar means 0.9999999 and so on. what goes on forever, but that doesn't mean it's I. Oh, first let's do R. And Q or I. Remember, Q includes anything that has a repeat. So this is Q, not I. Some kids say, oh, but it goes on forever. That's automatically I. No, I goes on forever in a non-repeating fashion. All right, and the last one, H, 0. Well, it's real. It stops. It's a complete number, so Z. And W includes 0, but N does not. So it's 4 of them here. All right. Next one. There are properties or rules that you must memorize. For addition and multiplication, they're separate. Commutative is if you have A plus B, you can change it to B plus A. So for example, if you have 3 plus 5, you can say, oh, I want to change it to 5 plus 3. It's still true. 8 equals 8. Same for multiplication. Instead of 2 times 3, you could say, well, let's do 3 times 2. 6 equals 6. Associative is when you change the parentheses move, not the letters. So A plus B is paired together, plus C by itself, changes to B plus C is paired together, and A is by itself. But the position stays the same. A is first, B is second, C is third. A is first, B is second, C is third. If there's plus signs, it's addition. If it's multiplication signs, it's multiplication. You could try 2 times 3 times 4. That's the same thing as 2 times parentheses 3 times 4. All right, next is identity. Your identity doesn't change. So this is where you have zeros and ones. When you have A, it's A plus 0 equals A. Well, you know that. And then 0 plus A is still A. Multiplication, what do you multiply by to stay yourself? A times 1 is A. All right, inverse is what you undo yourself by to get 0. So A plus negative A gives you 0. Then A times 1 over A equals 1. Closure just means if you add two numbers or multiply two numbers, it's still real. And distributive is a combination of both. You know, you have to distribute this, that's multiplication, and there's addition sign too, so it's not separated. So for commutative, associative, identity, inverse, closure, you have to tell me which one is the addition or multiplication. And I'll show you on the next slide. So these just memorize basically the formulas or patterns and just say the name. There's no work, just identify. So name the property. For A, I start with this and I end with this. So I figure out what happened, what changed. I noticed that we just distribute the 2 for 2x with 6. So this is the distributive property. That's all you write, distributive prop. Right, B, it started with this, 10 plus 0, and this became 10. What happened? Nothing really changed. You stayed the same, your identity. All right, C, you start with this, you end with this. What changed? The brackets moved. Remember, brackets are just like parentheses. So 2 and 3 were paired or grouped together in the first part. Now 3 and 4 are grouped together. So that's commutative property. Sorry, wrong one. Associative property. You tell me which one was the multiplication or division. I see a lot of multiplication signs, so I just say of multiplication, or you can just do parentheses and then the multiplication mark. All right, D. I start with this, 19 plus 2. I end with, or become 2 plus 19. What happened? They switched spots. The numbers commuted. Remember, commute means to move. I used to commute to work or commute to school. They switched spots. So I write commutative property. Commutative property. And then I tell of addition or multiplication. Well, there's an addition sign, so it's plus. In this last one, 9 plus negative 9 becomes 0. Well, that's just the inverse property of addition. All right, and I'll talk more about that on the next slide. All right, so this last slide, we talk about inverses. There's two, additive and multiplicative. Additive inverse just gets the number added to 0. So this is just the same number, but with the change sign. So what the full definition is 3 plus some number gets me back to 0. Well, if you do algebra, you just subtract 3 from both sides. You get x equals -3. So 3 and -3 are additive inverses. Next one, if I have -5, well, it's -5 plus some number gets me back to 0. If you do algebra, you just add 5 to both sides. You get x equals +5. So -5 and +5 are additive inverses. Some students say, well, do they just make there's 0 pairs? Yeah, they do, because 3 plus -3 is 0. -5 plus 5 equals 0. The shortcut or the trick is you just get the same number, but change the sign. So +3 became -3. -5 became +5. So for C, +10 becomes -10, and that's it. For if it's a fraction, same thing. If it was 2/3, it'll become -2/3. For the multiplicative inverse, you get a number to multiply to 1. And then the trick is just the same number as a fraction, but flipped. So let me do the full definition first. It's 3 times some number gives me 1. Algebra says just divide. So x equals 1/3. So 3 and +1/3 are multiplicative inverses. The next one, same thing. -5 times some number equals 1. Algebra says divide by -5, both sides. You get x equals 1/-5. So if you notice, it's a fraction. You just flip it, the sign stays the same. +3, +1/3. -5, -1/5. And we could make these all fractions by putting over 1, and you see it's just a flip. So for C, the trick, 10/1 becomes 1/10. Because 10/1 times 1/10 equals 1. Alright, here's the practice problem. Try it, the answer's there. If you can get it right, then you should be fine for the quiz. Thanks for watching, Mr. Wayne. See you in class.